Chapter 7. Heavy metal-induced neurotoxicity and amelioration through hypophy. Rhamnoids, seabuckthorn. Heavy metals appear in the mammalian system because they have become part of our environment. We are in a constant exchange with our environment, which is governed by the laws of osmosis. If mercury is in the fish we eat, over time we have mercury in our system. We cannot keep our system pristine and clean, because we are separated from our toxic environment only by semi-permeable membranes, skin and mucosal surfaces. Maintaining relative cleanliness requires a number of inherent detox systems to work overtime against the osmotic pressure of the incoming toxins. As the toxicity of our environment increases, so does the osmotic pressure, pushing often man-made poisons into our body. Toxins almost never come alone. They come in synergistically acting package deals. Mercury alone is toxic. Together with zinc, it is many times more toxic. Add in a little copper and silver, as in dental amalgam fillings, and the detrimental effect to the body increases manyfold. Together with mercaptan and thioether, dental toxins, the toxic amalgam effects grow exponentially. Add in a little PCB and dioxin, as in fish, and the illness-causing effect of the methyl mercury in fish increases many folds. Neurotoxins. Neurotoxins are substances attracted to the mammalian nervous system. They are absorbed by nerve endings and travel inside the neuron to the cell body. On their way, they disrupt vital functions of the nerve cell, such as axonal transport of nutrients, mitochondrial respiration and proper DNA transcription. The body is constantly trying to eliminate neurotoxins via the available exit routes, the liver, kidney, skin and exhaled air. Detox mechanisms include acetylation, sulfation, glucuronidation, oxidation and others. The liver is most important in these processes. Here, most elimination products are expelled with the bile into the small intestine and should leave the body via the digestive tract. However, because of the lipophilic/neurotropic nature of the neurotoxins, most are reabsorbed by the abundant nerve endings of the enteric nervous system (ENS) in the intestinal wall. The ENS has more neurons than the spinal cord. From the moment of mucosal uptake, the toxins can potentially take 4 different paths. 1. Neuronal uptake and via axonal transport to the spinal cord, sympathetic neurons, or brainstem, parasympathetics, from here back to the brain. 2. Venous uptake and via the portal vein back to the liver. 3. Lymphatic uptake and via the thoracic duct to the subclavian vein. 4. Uptake by bowel bacteria and tissues of the intestinal tract. Some of the common neurotoxins are described below in the order of importance. I. Heavy metals. Mercury, lead, cadmium, iron, manganese and aluminium are the most common. Common sources: metallic mercury vapor escapes from dental amalgam fillings. They contain about 50% mercury, the rest is zinc, silver, copper, tin and trace metals. Cadmium, car fumes, cigarette smoke, pigment in oil paint, lead, outsourcing from paint, residues in earth and food chain from time when lead was used in gasoline, contaminated drinking water, aluminium, cookware, drinking water. 2. Biotoxins, such as tetanus toxin, botulinum toxin, Botox, ascaridin, from intestinal parasites, unspecified toxins from streptococci, staphylococci, Lyme disease, chlamydia, tuberculosis. Fungal toxins and toxins produced by viruses. Biotoxins are minute molecules, 2001000 kilodaltons, containing nitrogen and sulfur. They belong to a group of chemical messengers which microorganisms use to control the host's immune system, host behavior and the host's eating habits. 3. Xenobiotics, man-made environmental toxins. Such as dioxin, formaldehyde, insecticides, wood preservatives, PCBs etc. 4. Food preservatives, excitotoxins and cosmetics. Aspartame, diet sweeteners, MSG, many spices, food colorings, fluoride, methyl and propyl, paraben, etc. Heavy metal. Heavy metals. The term heavy metal is really a misnomer. In chemistry, such a thing as heavy metals does not exist. Chemistry talks about transition metals. There are 38 metals in that group of transition metals. Parts of the groups are lead, mercury, cadmium, zinc, copper, iron, nickel, and so on. Some of these metals, e.g. lead, mercury, cadmium, etc., are also called toxic metals. They are called toxic because unlike zinc, copper, iron, and so on, they don't seem to have any beneficial value for the body. 9. We have known for some time that these toxic metals can build up in a human body and cause untold mental, emotional, and physical suffering. For a long time, we have no idea why these metals would accumulate more quickly in some people and slower in others. Today, we know that this has something to do with the ability of a person to engage the outer electrons of the metals, bind or chelate the atom they are part of, and hence, make the ionic equals electromagnetically charged metal atom electromagnetically neutral, i.e., the metal cannot stick to the body like the blotting paper to the glass rod, or the hair to the balloon we rubbed against a woolen jumper, and cannot produce avalanches of free radicals either. But what about other metals? What about copper, zinc, iron, etc.? They are sometimes called essential metals. Without them we could not survive, let alone lead a healthy life. Over the last 30 years or so, since research into free radicals has really taken off, we have become aware of the fact that these essential metals can kill us as well. We have learned that ionic, electromagnetically active, metals produce avalanches of free radicals. Scientists believe now that free radicals are the root cause of all chronic diseases from rheumatism to arthritis, diabetes, Alzheimer's, Parkinson's, MS, MND, asthma, cancer, and even aging. There are 35 metals that concern us because of occupational or residential exposure. 23 of these are the heavy elements or heavy metals: antimony, arsenic, bismuth, cadmium, cerium, chromium, cobalt, copper, gallium, gold, iron, lead, manganese, mercury, nickel, platinum, silver, tellurium, thallium, tin, uranium, vanadium, and zinc. Glanz 1996. Interestingly, small amounts of these elements are common in our environment and diet and are actually necessary for good health, but large amounts of any of them may cause acute or chronic toxicity, poisoning. Heavy metal toxicity can result in damaged or reduced mental and central nervous function, lower energy levels, and damage to blood composition, lungs, kidneys, liver, and other vital organs. Long-term exposure may result in slowly progressing physical, muscular, and neurological degenerative processes that mimic Alzheimer's disease, Parkinson's disease, muscular dystrophy, and multiple sclerosis. Allergies are not uncommon, and repeated long-term contact with some metals or their compounds may even cause cancer. International Occupational Safety and Health Information Center 1999. For some heavy metals, toxic levels can be just above the background concentrations naturally found in nature. Therefore, it is important for us to inform ourselves about the heavy metals and to take protective measures against excessive exposure. In most parts of the United States, heavy metal toxicity is an uncommon medical condition. However, it is a clinically significant condition when it does occur. If unrecognized or inappropriately treated, toxicity can result in significant illness and reduced quality of life. Ferner 2001. For persons who suspect that they or someone in their household might have heavy metal toxicity, testing is essential. Appropriate conventional and natural medical procedures may need to be pursued. Dupler 2001. The association of symptoms indicative of acute toxicity is not difficult to recognize because the symptoms are usually severe, rapid in onset, and associated with a known exposure or ingestion. Ferner 2001. Cramping, nausea, and vomiting, pain, sweating, headaches, difficulty breathing, impaired cognitive, motor, and language skills, mania, and convulsions. The symptoms of toxicity resulting from chronic exposure: impaired cognitive, motor, and language skills, learning difficulties, nervousness and emotional instability, and insomnia, nausea, lethargy, and feeling ill, are also easily recognized. However, they are much more difficult to associate with their cause. Symptoms of chronic exposure are very similar to symptoms of other health conditions and often develop slowly over months or even years. Sometimes the symptoms of chronic exposure actually abate from time to time, leading the person to postpone seeking treatment, thinking the symptoms are related to something else. Definition of a heavy metal. Heavy metals are chemical elements with a specific gravity that is at least 5 times the specific gravity of water. The specific gravity of water is 1 at 4 degrees Celsius 39 degrees Fahrenheit. Simply stated, specific gravity is a measure of density of a given amount of a solid substance when it is compared to an equal amount of water. Some well-known toxic metallic elements with a specific gravity that is 5 or more times that of water are arsenic, 5.7, cadmium, 8.65, iron, 7.9, lead, 11.34, and mercury, 13.546, Lied 1992. Beneficial heavy metals. In small quantities, certain heavy metals are nutritionally essential for a healthy life. Some of these are referred to as the trace elements, e.g., iron, copper, manganese, and zinc. These elements, or some form of them, are commonly found naturally in foodstuffs, in fruits and vegetables, and in commercially available multivitamin products. International Occupational Safety and Health Information Center 1999. Diagnostic medical applications include direct injection of gallium during radiological procedures, dosing with chromium in parental nutrition mixtures, and the use of lead as a radiation shield around X-ray equipment. Roberts 1999. Heavy metals are also common in industrial applications such as in the manufacture of pesticides, batteries, alloys, electroplated metal parts, textile dyes, steel, and so forth. International Occupational Safety and Health Information Center 1999. Many of these products are in our homes and actually add to our quality of life when properly used. Toxic heavy metals. Heavy metals become toxic when they are not metabolized by the body and accumulate in the soft tissues. Heavy metals may enter the human body through food, water, air, or absorption through the skin when they come in contact with humans in agriculture and in manufacturing, pharmaceutical, industrial, or residential settings. Industrial exposure accounts for a common route of exposure for adults. Ingestion is the most common route of exposure in children. Roberts 1999. Children may develop toxic levels from the normal hand-to-mouth activity of small children who come in contact with contaminated soil or by actually eating objects that are not food, dirt or paint chips. Dupler 2001. Less common routes of exposure are during a radiological procedure, from inappropriate dosing or monitoring during intravenous, parenteral, nutrition, from a broken thermometer, Smith et al. 1997, or from a suicide or homicide attempt, Lupton et al. 1985. As a rule, acute poisoning is more likely to result from inhalation or skin contact of dust, fumes or vapors, or materials in the workplace. However, lesser levels of contamination may occur in residential settings, particularly in older homes with lead paint or old plumbing. International Occupational Safety and Health Information Center 1999. The Agency for Toxic Substances and Disease Registry, ATSDR, in Atlanta, Georgia, a part of the U.S. Department of Health and Human Services, was established by congressional mandate to perform specific functions concerning adverse human health effects and diminished quality of life associated with exposure to hazardous substances. The ATSDR is responsible for assessment of waste sites and providing health information concerning hazardous substances, response to emergency release situations, and education and training concerning hazardous substances. ATSDR Mission Statement, November 7, 2001. In cooperation with the U.S. Environmental Protection Agency, the ATSDR has compiled a priority list for 2001 called the Top 20 Hazardous Substances. The heavy metals arsenic, 1, lead, 2, mercury, 3, and cadmium, 7, appear on this list. Asterisk note, the ATSDR provides comprehensive protocols called Medical Management Guidelines for Acute Chemical Exposures in Volume 3 of the Managing Hazardous Material Incident Series. These protocols have a chemical abstract service, CAS, number and give a description of toxic substances, routes of exposure, health effects, pre-hospital, triage, and emergency medical department care, antidotes and treatment, disposition and follow-up, and reporting instructions. The series may be viewed or downloaded from the ATSDR website at no cost. Commonly encountered toxic heavy metals. Arsenic. Lead. Mercury. Cadmium. Iron. Aluminium. As noted earlier, there are 35 metals of concern, with 23 of them are called the heavy metals. Toxicity can result from any of these metals. This protocol addresses the metals that are most likely encountered in our daily environment. Briefly covered are B4 metals that are included in the ATSDR's Top 20 Hazardous Substances list. Iron and aluminium are also discussed even though they do not appear on the ATSDR's list. Arsenic. Arsenic is the most common cause of acute heavy metal poisoning in ADU and is number 1 on the ATSDR's Top 20 list. Sources of exposure: air pollution, antibiotics given to commercial livestock, certain marine plants, chemical processing, coal-fired power plants, defoliants, drinking water, drying agents for cotton, fish, herbicides, insecticides, meats, from commercially raised poultry and cattle, metal or smelting, pesticides, seafood, fish, mussels, oysters, specialty glass and wood preservatives. Target tissues: most organs of the body, especially the gastrointestinal system. Lungs and skin. Signs and symptoms: abdominal pain, burning of the mouth and throat, cancer, especially lung and skin, coma, diarrhea, nausea, neuritis. Peripheral vascular problems, skin lesions, and vascular collapse. The greatest dangers from chronic arsenic exposure are lung and skin cancers and gradual poisoning, most frequently from living near metal smelting plants or arsenic factories.